Let's calculate and interpret a confidence interval in a specific situation. So, example, in a video game, some enemies drop fire gems when defeated, and you want to know what proportion of the time this happens, so you spend a few hours defeating enemies, and you get 57 fire gems from 407 enemies. So kind of a callback to our gaming module here, and the idea that statistics ideas can sometimes go together. So the calculations here, you'll calculate p hat, which is just your number of successes over your sample size, so 57 successes over 407 trials. You end up with just a hair over 14%. Standard error of p hat, you'll go ahead and do the square root of this number, and I'll just click it here instead of typing it in again, times 1 minus that number, and divide by the sample size of 407, like so. Just using this formula down here, and you get about 1.72%. Now Z star, we're just going to look up in a table, so same table as last time. It doesn't specify in this problem, actually there aren't any directions here at all, but let's assume that it says make a 95% confidence interval. So we'll use Z star as 1.96. We have all the pieces here, so we just have to put them together. The lower end of the interval is going to be this formula, just using the minus instead of the plus. So we'll do p hat minus Z star times the standard error. So just like that, we get 10.633%. The upper will do the exact same thing. We'll just use the plus sign in this formula. So you'll do p hat plus Z star times the standard error, and you'll get 17.377%. If you wrote that as an interval, you can use decimals or percentages. You might write it as 10.6%, 17.4%, like so. And now it's written as an interval, and of course, every time we do this, I'm going to have you interpret it. So the interpretations always kind of work the same way. We are 95% confident that the proportion of enemies that drop fire gems is between 10.6% and 17.4%. So that's it. You don't know what proportion of time the enemies actually drop fire gems, but you have an interval estimate around it, and you have a certain confidence level. Of course, after you do this, you can just go ahead and look it up in some online wiki and just get the answer right there, but let's pretend we didn't have that available. The other thing we might do is we might calculate the margin of error. We don't really need it in this case, but just as an example of how to do it, you just do Z star times the standard error, and you get, it's about, if you format that as a percentage, you get about 3.4% is the margin of error for this interval. So 14% plus or minus 3.4% is your, it would be another way to express the confidence interval.